Hello, welcome back to Cracking the Cryptic. Now, I understand there is a worldwide gas shortage, which is causing wholesale gas prices to go through the roof. But there's no shortage of gas on this channel. Today, we will be looking at another 5 genuinely approachable Sudokus or gas puzzles from the Discord server, where the daily puzzle channel features one of these a day. And if I don't get on with them all, I will never catch up. But we're recording this on the 23rd of September, and I'm solving puzzles from the 5th to the 9th. So I feel like I'm getting closer, but it's never that close. Anyway, we'll do those in a minute. First of all, just want to mention that on Patreon we do have the Looney Tunes Sudoku Hunt solution, so you can find out who won the sandwich there. We've also got Sam Cappleman-Lynes' 6x6x6 Sudoku, a very interesting exercise in sort of disjoint subsets across 6x6 grids. Certainly well worth a try. What else have we got going on? We've got all the merchandise and the apps. They're all in the links under the video, but the first 5 links are to the 5 puzzles I'll be doing today. Now, I'm very grateful to Sam, Philip and Clover, the creators of these puzzles, that they create links to the puzzles in our software. But it means that I've basically just clicked on those 5 links. I've got the puzzles loaded up. I haven't even looked at the rules yet. So I will take you through the rules of all 5. Then I will try and do them as quickly as I can and see how many hats I can earn as a result. A quick time, these are dependent on the puzzle length, earns 2 hats, and a slower time 1 hat, and a dinosaur if you just get the solve done in the end, which is often what happens if I make a mistake at some point. So we'll see what happens today. So we start with a puzzle called multiplication. In each shaded 2x2 area, the 2 single digits on the top row must multiply to give the 2-digit number in the bottom row. So the 2 digits there multiply. So it could be, let me just try and come up with an example that would work here. It's difficult, like let's say 3 there and 6 there would give 18 down here. And you would read that as 1/8 in that way. So digits may repeat in a shaded area if allowed by the normal rules, of course. That's the first puzzle, a bit like one we set in the Hitchhiker's Guide, although hopefully this one uses base 10. Right, next one is Pisces 5 by Philip Newman. As usual, I have no idea what Philip Newman's titles mean, although I can kind of see a fish shape going around here, maybe, when the given digits in this classic Sudoku. Normal Sudoku rules apply, and that's it. Then we have a Windoku, which is a reasonably familiar form. Some newspapers have this. The digits 1 through 9 must appear exactly once in each shaded region, so that'll have the digits 1 to 9 in. Oh, then Antiwindoku. These guys don't just throw these things together. That's obviously a plan by Clover and Sam. So I hate these. The shaded areas here, now they don't contain the digits 1 to 9. As you can see from this one, that can't be the case. There's 2 7s in there. Each shaded region contains exactly 4 distinct digits. So there are only 4 digits that are used in each shaded region. That's a really, I'm going to warn you now, if that's approachable, I'll be impressed. That is a weird rule set, and I have struggled with it once or twice before. And then a puzzle called Queen by Philip Newman. Digits along a line must have values strictly between the values in the circles on the ends of that line. That's a between lines rule. So these 2 digits, whatever's in them, those numbers must come between the 2 numbers in the ends. Digits in a white circle must appear in the 4 surrounding cells in any order. So those 4 cells must be 2, 3, 6 and 8. Now, it's called Queen, but it's not what we would call Queen Sudoku. It's basically a mix of between lines and quadruple. So those are the 5 puzzles for today. Do have a go. Oh no, that's not the first one. That's the first one. Do have a go in the links under the video. I'm going to start now. Let's get cracking. So, got 4, 4. That gives us a 4 here. Couldn't have gone there because 41 is prime. In fact, what can this be? 21. Can't be 51. It's got to be 21, hasn't it? 31 and 41 are prime. 51's too high. Yeah, 51 has 17 as a factor anyway, so maths to the rescue. Now there must be a 2 in one of those two cells, which could be, well, it could be very useful. What's 4 times... No, maybe not. Let's do something else. Let's put an 8 in one of those. That is interesting. Now this can't be 32. So it's either 12 or 24, no, 28. 12 or 28 must be the sum here, I reckon. Now that it can't be 32, because 8 can't be there. So this is a 7 or a 3. Maybe I'm focusing on the maths too quickly. 5 and 6 have to be up here. Oh, this is a naked single 9, is it? Yes, it is. That's what I should have spotted. And I'm absolutely right that a bit of Sudoku would have helped more than delving into the multiplications. 5, 6, 8, 4. Oh, 5, 6. 5 and 6 must be down here. Oh, 9 times something. And it can't begin with 1 or 2. I suppose it never has to with 9. In fact, these two will have to add up to 9 by the rules of 9 multiplication. So they could be 36 or 63. 45 won't work. That would need a 5. But 54 will work. So there's quite a few possibilities there. It's got to be a 4 in this area. So it's either 54 there or 4 there. So it's not 7 and 63. There's got to be a 4 because of the position of that 4. I don't feel I'm being quick here. So 8's in one of those two cells by Sudoku. We've now got 4, 6 and 2. So that's not a 6. That's not a 2. Oh, we knew that. We knew there had to be a 2 there. Oh, come on. 9, 4 pair, 9, 4 pair. We get a 9 in one of those and a 4 somewhere. There has to be a 1 in here. It could be there. Oh, it can't be up here because 1 times something doesn't give you a 2-digit number. Right, so that was a useful conclusion. 3, 5, 6, that gives us a 7. It gives us an 8. This is now 2, 4, 9 up here. That one can't be 2 and that one can't be 9. Has that resolved anything else? What about this? 18 can't be 28 now. 48 won't work because we can't have an 8 up here. Anything else is too high, so it is 18, and it must be 3 times 6 because it can't be 9 times 2 now. Okay, how is that going to help? 4, 6, oh, this 1, yeah, that fixes 8, 2, 1. So this is a 3. That makes this a 5, so this is 50. Have I done my maths wrong? 9, 6 is a 54. I haven't. I'm sorry. I had a momentary burp in my understanding of maths there. 4, 3, 5, 6, 8. That is 7 or 9. 1, 2, 3, 4. Okay, 8 times something. Oh, and it's got, this can't be 1, 2, or 3. So 8 6s can't be 48. That won't work. 8 7s are 56. That's probably what it is. 8 9s won't work because we can't put 72 in. Oh, it's been very straightforward. If I could just spot the useful clues. Right, 1, 8, 5, they go in. Now that 8 fixes the 7, 3, 8 triple. Have I not fixed the 4, 2, 9 triple? Not yet. That's surprising. 6, 4, 2, 8, 3, 1. So that's a 1. That's a naked single 4. That must be 2. That's 5. 5, 6, 7, 8, and 6. That's a naked single 6. And that fixes a 7 there. That puts a 9 here. I think we can get into finish off mode now. Haven't really hit full beast mode for a long time, so let's see how we can do. 6, 1, 8, 2, 7, yes, they're done. 2, 7, 3. 4, 5, 9. Yes, that has to be 5. In fact, that has to be a 5. 4 and 9 in those two. 3 and 2, they go in. 9 and 7, they're resolved, so these two must be done. 5 and 6 pair. That looks right. Now we still don't know whether that's 4 or 9, but it forms a pair. 2, 7 and 6. So that's 2 or 7. That's where 6 goes. Right, and now we do know the last deduction. 2 there, 7 there. That makes that 2, 1, 7. We get a 1 at the top and a 4 there. This is 9, and then we can go 4. Oh, I did not set off the clock on this one, so I don't quite know what time I've done. Probably about 6 minutes, which may not be enough to get the 2 hats. We shall see. Right, classic. Let's restart this and get going. Okay, so there's a lot of digits given. It's probably got a wicked sting in the tail, knowing Philip. Making it an electric eel or something. That's a 2. 3, 9, 8, 5, 2, 6 in one of those. 1 there. 5 at the top. I'm finding lots of positions for 2 cells and not many absolute givens. Oh, that's a naked single 4. I suppose, I mean, spotting naked singles is so difficult sometimes, but that finishes column 2 suddenly. Let's just get rid of the bad pencil marks now. 5, 1, 8, 2, 3. 4, 9, 7, 6. Don't know what to do with that. How about this 8? Yes, that fixes 8 there, clearly. And an 8 up here. 9's in one of those 2. 1, 5, 6, 4. Oh, 4's down there. That doesn't get anything done. That's 2 or 7 just by Sudoku. Ah, they can't be 3, so it's a 1, 7 pair. Right, in fact there's a 3 here, so that's useful. So we've got 4 and 9 to fit in that row. So 8, 2 and 6. 2, 9, that's a naked single 7 there. 3, 6. Useless triple going on. One of those is a 7. That doesn't really help. Come on. Oh, this is a naked single 1 there. So we can do 6 and 4 in column 5. 6, 1, 4, 3, 8. 1 is in one of those 2. 2 must be there. So 2's in one of those. Don't know about 5 and 7. Those are from 1, 2 and 7. I suppose by uniqueness it can't be a 1, 7 pair. Ah, that's an X-wing on 1s, so there's going to be a 1 down here somewhere. 9 in one of those 2 cells. 6, 2, 3, 5 down here. Yeah, I'm certainly still missing something. Ah, 3. There's only one place in this box. And that doesn't get anything done. Oh, look, I've got a 4 looking up there. So it was naked the whole time and I couldn't see. Oh, hang on, something's gone wrong there. No, it hasn't. That's a 4, that's a 9. That's all right. 5, 3, that's a 6 now. 7 and 4 are finished off, so that's a 6. This is now a 2, 8 pair. That's where 6 goes in the column. So 1, 8, 7 down here. I hope I haven't made a mistake. Something felt a bit odd earlier. I hope that's not a good instinct. 6, 5, 7. But 1 is placed in this central box now. 6, 9, 4, 3, 8, 1. That's 2 or 5. So there's definitely a 2 there. That's not interesting. That can't be a 1. Oh, those can't be 9, so the 9 in the row is here. That places 5. Then we've got a 7, 9 pair. They're done. That does 9 over in the final column. That That is now a naked single 1. So we've got a 2, 4, 6 triple. That's naked as well. Loads of naked singles all over the place in this puzzle. We get a 5 here. 1, 8, 7 triple still to finish. 9, 3, 2, 8, 6, 4. So that's a 1, 7 pair. That's a 5. There is a uniqueness play that I could be using, but let's not do that, even though we're going at full speed. And again, I'm still hoping I haven't made an error. The good thing with a classic is there's no rules I can have disobeyed. So if the app tells me I'm right at the end, I must be. 7 there. Okay, 8 and 7, 8 and 1. There we go. So 4 minutes 53. It's a good puzzle. I mean, that's not a complete giveaway. Nice stuff there from Philip, as usual. Don't know, might just have earned the hat. I suspect 5 minutes will be the maximum the 2 hat time could be. Right, let's move on to the Windoku. So let's restart my clock. Here we go. Now it's always a puzzle which clues are more important in this. 1 there. Now there's got to be a 1 in this window, and it's got to be there. This window needs a 1 in one of those 2 cells. That must be a 1 as a result. Columns 8 and 9. Suppose there's got to be a 1 here. That's a sort of X-wing left over at the end. 7, 2, 6. Where's the 8 going to go in this window? It's here, isn't it? That 8 sees every other cell, and that 9 sees every other cell. My goodness. So this is a 5, 1, 4, 3 triple in a hideous chocolate teapot arrangement, but nevertheless, as soon as we get one of them, we'll get all of them. That's 5. Oh, this is fine now. 4, 1, 9, 5, 7, 8. Now, 4 in this box has to be there because it can't be in the window. That's an 8, 9 pair. That's a 6, 7 pair. 2 and 3 to finish the window. Suddenly they're quite easy to do. 6 and 3 there. That does fix the chocolate teapot quadruple, and the top 3 boxes are done. Now 7 in this window must be here. Is there always a giveaway number in each window? I don't know. That's got to be a 5 for the column. Then we have 8 there by Sudoku. 2 and 9. This is 2, 6 and 7. Actually, they can be filled in. And now this window is pretty much done. Can finish it off. 7, 5. So there's got to be a 5 in this window. It's got to be there. 4 has to be here. That must be a 9. And that's a 2, 3 pair. So we can forget the windows now. They are done. 3, 8, 5 here with a 3 there. 9 and 6 down here. Yes, that's a 2. That's a 3. That fixes the 2, 3 pair. 2, 4. We've got 3, 7, 6. 7, 6, oops, 6, 3. Final column 4, 8 and 7. Must be able to do them. We can. Central column 9, 8 and 5. 7 and 6 in the middle row, and just column 1 to finish off with 8 and 5. That's a pretty quick time. 2 minutes 40 seconds. Give me the 2 hats this time. I reckon I earned them. I mean, it was very useful. There were a couple of positions where there were numbers that just could be written into the window immediately. That 8 saw all of those cells, and that 7 saw all of those. So that is quite generous as an introduction to Windoku by Clover. Right, let's have a look at Sam's Antiwindoku. Now, as I said, these can really throw you. I might just start with regular Sudoku. Let's go. So, 1 and 2 can't be in those cells. So they're definitely in this area. Yeah, this is a good thing, is these 4 cells in each of these windows must always be the 4 digits that are in. So 5 and 6 are in this one. So this has to be a 1, 2, 5, 6 box, as it were. So we get 6 there. Let's just take out that pencil mark and put in 1, 2 there, and 1, 2 and 5 here. And that has to be 1, 2, 5 or 6, and that similarly, but I don't know whether it's 2 or 5 this time. Now, what can we do here? 3 has to be in, and 4. Yeah, normally when you get these puzzles, you don't get so many givens in the windows. But I don't know quite what to do with that. That puts a 4 here. 3. So that's an 8, 9 pair. Let's try down here. 9, 2 and 1 are, 4 and 8 are in this window, of course. 9, 2 and 1 aren't. 6 isn't. That's a 6. 9, 2, 1, 6. So 7 and 7. Oh, but I don't know there's a 7 in the window. There probably isn't, in fact, given that you couldn't get a second one in. I don't think that's proved. I once struggled through one of these puzzles believing that you always had to have 2 of each digit or something. I don't know, and it turned out to be a completely false conclusion. 2, 2, that's not a 2, and that's not a 2, that's a 2. 5, 6, 4, 3, 8 and 9. Oh, it's so different from the other form, from the Windoku form. 2, 6, 1, 4, 9, 8. I just don't know whether 3, 5 or 7's in it. Ah, look, 5 can't be in those cells. Again, that doesn't quite prove anything. Let's have a look at this. 7 and 5 are in. So one of these is a 7. It's got to be there. 5's in one of those cells. Does that 7? Yes, that gives me a 7 down here. That's what I should have done. So now we've got 3, 8, 4 and 5 in this one. So their numbers are always made up in this window of 4, 8, 3 or 5. So they can be filled in. So that's the 4. That's the 8. That's the 5 and that's the 3. Right. So we've got 1, 9 and 6. So 2 of 1, 6 and 9 are definitely in this window. But 6 can't be in those cells. So they're made up of 5, 1 and 9. Doesn't place 2 for me. Oh, that's a naked single 6. Those two are 7 and 9. 6, 6. So that is a 6 by good old Sudoku rules. So 6 is in. That doesn't make that necessarily a 6, although one of those two is. That is a 9 out of its possibilities. That's quite surprising. Ah, that fixes the 8, 9 pair at the top. And that makes the 7, 9 pair in column 6 done. That's a 5. Oh, this is useful. 1, 5, 2, 4, 5, 2, 6, 8. That has to be 1. That's a 7. So this is 9 and 3. This is 8 and 4. Yes, we know the order. So everything in this window is from 3, 8, 4 and 9. That one's an 8. That is 3 or 9. So is that. That 8 has fixed the 6, 8 pair. The 1 has fixed the 9, 1 pair. That fixes the 9, 3 pair. Oh, this has come, right, this has come a bit better than I was expecting. 2, 5 pair there. 6 and a 4, 7 pair. 1 and 2 here. Yes, they're done. Oh, 6 wasn't in that. In row 6, column 3, which surprised me. 8 and 9 down here. There we go. So now 1 and 5 are in there. 9 couldn't have been for a while. 2. That's now become a 2, and that's 1, 5 like that. So 1, 7, that fixes the 4, 7 pair. That fixes the 4, 5 pair. What have we got here? 3 and 5. There we go. Wow. I mean, it's an interesting puzzle. So it ended up with 1, 2, 5, 6 in that one, 4, 3, 8, 9 in that one, 1, 5, 6, 7 there, and 3, 4, 5, 8 there. And as I say, I once tried one of these puzzles on the assumption that you always had 3 of one type and then 2 of each other type. But as you can see here, there's 3 of 8, 3 8s, 3 4s, 2 3s, and only 1 5. Whereas up here, you've got 3 9s and then 2 of each other type. So I'd kind of assumed a rule that didn't exist when I struggled with one of those before, but that's a nice puzzle. What was the time? 5 minutes and 8 seconds. That should be all right. Right, and we've got one more. Oh yes, this quadruples and between lines mix. That doesn't promise to be easy, but maybe the quadruples will help. Okay, off we go. So 1, 2, 4, 5 there. 5 is the shared digit between these two quadruples. 3 and 7 must be in those cells. That one can't be a 7, so it's a 3. What else is shared here? 8 between those two. 9 there. Okay, those are coming fairly quickly. 3, 7, 8, and 9. So that's a 3, 8 pair. This is a 5, 7 pair. We know the order. That's good. 7, 4, 1, 3. This can be 4 or 1. This can be 4 or 2. So it didn't get right. There's a 3 in one of those cells. 1 can never be on a line. 1 and 9 can never be on a between line. That's quite a useful tip there. So that sorts out 3 and 7. 7 and 8 are used in this row. So that's a 2, 4 pair. That's a 7, 8 pair. Five has to be there. That's 2 or 4. 1, 2, 8, 9. That's no use. Right. Need to think of something else. There's definitely a no. There's definitely a 3 in one of those cells. I was going to say a 1, but that's the wrong conclusion. Right. Now here, trouble is that could be 4 and 7. This can't. These must be from 1 and 2 and 8 or 9. That one can't be 8. That one can't be 9. Oh, here again, 1 and 9 off the line. Right, 2 and 8 on the line. That's a better place to start. Therefore, 1 and 9 in the circle. Now, whichever one's a 1, that can't be a 1. Come on, that's got to be helpful. That's a deep conclusion. So we get 2 there, annoyingly 4. The 2 fixes the 2, 8 pair. That fixes 7 and 8. Right, again, these are from 1, 2, 3, 8, and 9. Now, how much can I narrow those down? That's not a 9. That's not a 1. I can't narrow them down much at all. Bother. 3, 8. Oh, that can't be 3 or 8 because of what's in its box. That can't be 3 as well. Okay, they're getting more narrowed down. There's a 1 there, so that's a 9. That's a 2. This has to be high, so it's an 8. This is a low, so it's a 1. This has to be low, so it's 1 or 2. This has to be high, so it's 9. Haven't really had a chance to have a go on this one. 2 in one of those, 8 in one of those, 3 in one of those. I don't know, maybe that's not interesting. 2, 4, 5, 9. Oh, the 2 at the bottom has fixed those. This 3, 4 pair still not resolved. Can't see if it is. This is 1, 2, or 7. This can't be low. It has to be 6, 7, 8, or 9. This can't be 7 anymore then. This has to be low. Yeah, that's got to be right. 4 in this column is here. 1, 2, and 7. That's 1 or 2. This is a 7. 3. Oh, that's a 1. Sorry, I didn't see the digit. Right, 2 there. So 2 can't be on the line. That must be 2. This, I don't know. Well, 6 at least has to be on the line. Okay, I know that much. 1, 3, 4, 8. 2 in this box. Can we finish off all the 2s? And that's a useful one. Yes, we can. I think they're all done. Right, that one. Oh, didn't get any other ones done. 3, 4, 2, 7 here. Got a 5, 6 pair. Right, now I can tell that's a 9. That's 1. That does resolve the 1 9s. 2, 8, 9. 5 and 6 to go in the ends of that row, and I can't do them. 2, 7, 5, 4, 9. So, oh, good lord. Oh, that's got to be where 3 is. Then we've got a 6, 8 pair there. 4 and 1, they can go in. Right, 1 there. Surely we can do the 1s now. Don't think we can still. Oh, yes, we can. That becomes a 1. So that does fix the 1 here. And that becomes a 1. And I think the 1s are done now. That's got to be a 9. So that can't be. So this can't be 8 anymore. Yeah, you have had to know a bit about how between lines works for this puzzle, which has been surprising. 5, 7, 2, oh, 7 in the box. 6 and 5, still can't do that 3, 4 pair, but 3 is there, now I can. 4, 3, that's a 4, that's a 9, we've got 5 and 8 for the column. 5, 6 pair that I can't resolve at the end. 4, 7, 9, I can do those at the top. That's an 8, we've got 3, 4, 6 across the top, they can be done. 5 and 7, that fixes this 6, 5 pair finally. 3 and 5, now I can do the 8, 3, and 6 and 3 to finish off. There we go. So that time, 6 minutes 23, I would hope that that is still a 2 hat time. Might just have got a clean sweep on the hat, although I don't know what time I did on this first puzzle. The second, yeah, that should be all right. The third, definitely. The fourth, yeah, probably. It's not a bad set of times. I hope you enjoyed those puzzles. They were very interesting, I thought. A really nice set from Sam, Philip and Clover, to whom we, as always, send our thanks for keeping the gas pipeline flowing here on the channel. At least that is not a problem. And I hope to bring you more of these in another few days. As it is, bye for now.